Welcome again. Let's check our second factor of factors affecting the rate of photosynthesis. And today, let's focus on light intensity. We're speaking about what? Light intensity. And I'll use a graphical again still model of what we had been discussing. And the light intensity will not be as that for the temperature. For the temperature, we said it was rising, then decreasing. But for the light intensity, it will increase, then it becomes constant. So we are saying it will do what? It will increase, then becomes constant. So this one is your light intensity. Temperature was in degrees Celsius. Light intensity is in arbitrary units. Arbitrary what? Unit. Then this one is your rate of photosynthesis. Your rate of photosynthesis. Still, let's make this first point to be point A, point B, and C. This one still, it can be an essay question when it's full, the factors affecting photosynthesis, or it can be a graphical question when it's this one alone. I mean, when you are just asking about what? The light intensity. So still, let's just do the way that we did the other one. Explain photosynthesis at point what? A. You are saying you're explaining photosynthesis at this point A. Just like the temperature at point A, you can check our light intensity is low. Before we do that, what is the role of light when it comes to photosynthesis? The role of light is for the photolysis of water. Light, we are saying what? Role of what? Light is to do what? For photolysis of water. It's for the photolysis of what? Water. So, and we are saying here, when the light is low, so we are saying low light intensity leads to low rate of photosynthesis. I don't know if you are getting this one. The main reason when you check this one, let's say this one is 1, 2, as we continue. Then this one you can check it's around 0 point something. So with the low light intensity, you will be given in terms of values. Mine is just a sketch. So we are saying when the light intensity is low, the rate of photosynthesis will also be low. So, and because of what? What's the main reason? We are saying the role of light is for photolysis. So the main reason is what? Because of low photolysis of water. I don't want to go deep. When you speak about the low photolysis of water, the role of light is to split the water molecules to hydrogen atoms and oxygen gas. So during the light stage of photosynthesis, that is what happens, the photolysis in the presence of light. That's why it's light dependent stage. So because of that, now we split the water molecules to the hydrogen atoms and the oxygen gas. And what will happen to these hydrogen atoms is the one that will enter the dark stage, which will now combine with the carbon dioxide. In the process of carbon dioxide fixation, we form a simple sugar that is now leading to increase in the rate of photosynthesis. So the low the light and the low the photolysis. The low the photolysis, the low the breakdown of this water to hydrogen atoms. And when we have less hydrogen atoms, there will be less hydrogen atoms combining with carbon 4, hence leading to low formation of the glucose. And that's why we are speaking about what? Low rate of photosynthesis. Let's explain at the point A and B. Explain at A and what? B. What happens from this point to this point. The first mark is always a free mark. We're speaking about as you increase your light from this point to this point, you can check the rate of photosynthesis also is what? Increasing. So we are speaking about what? Increase in light from point A and B, from point what? A to B, leads to increase in the rate of photosynthesis. You get your first mark. The main reason, what's the main reason? And the main reason is because of what? Increased photolysis of water. So we are speaking about what? Reason because what? Because of increased photolysis of water. You get your mark. Hence increasing what? That rate of photosynthesis. And you have understood how you'll explain in case it demands you more marks. Then explain at B and C. Explain at B to C. You can check it's constant, but now you are still increasing light intensity. You have not stopped increasing the light intensity. So it's further increase. Further increasing light intensity, the rates of photosynthesis remains constant. That is a free mark. Does not require an explanation. You're further increasing from point B and C. The rate of what? Photosynthesis we are speaking about will remain constant. Why is it remaining constant? Why it's remaining constant? Because of other limiting factors. So we are not speaking about photolysis here. Because of what? Because of other limiting factors. Which are those limiting factors? E.g., temperature and CO2. That is it. So we are saying it's remaining constant because of other limiting factors. And we are saying limiting factor is temperature. During photosynthesis, this is a process which takes place during the day in the presence of light. That is for the day neutral plants and short day plants, but not for the long day plants. It will happen on the long day plants for some hours, but in the other hours where we have low light, we supplement them with artificial light. So the other light that we're speaking about, natural light, that's sunlight, for the normal plants, which is what? Short day plants and the day neutral plants. But for the long day plants, they have to be given some extra hours of light. So we're speaking about this point. Let's say it's noon, afternoon, right? Towards the evening, the temperature tends to go down. And again, the carbon dioxide concentration might become low. And because of this one, what will happen? The rate of photosynthesis will remain constant at that moment. But this one can be easily regulated when it comes to the greenhouse. Because greenhouse, you can add your carbon 4 and even you can add what? Your temperature. Then from that point, how can you increase from point B? So we are speaking about what? How to increase from point B. And how do you increase from point B? By doing what? Correcting the limiting what? Factors. Correcting the limiting factors. You correct the limiting what? Factors. Then what happens to the extreme light intensity? Let's take an assumption that this one was at 20 arbitrary units of light. What will happen at 30 arbitrary units of light? What happens? Too much light. What happens We are speaking about what? What happens in case it's what? What happens in case we have extreme light intensity? And the reason why what will happen when we have extreme light intensity, it will cause the bleaching of the chlorophyll. We are speaking about what? What happens in case of too much light? Too much light what? Intensity. And I've said causes bleaching of chlorophyll. And if you are told, can you predict at the other units, maybe that it will go and behave in this manner? It will start to decrease. It will start to do what? To decrease in case the light is too much. When you're told, you extrapolate. When you're told you extrapolate, what happens? That light intensity will start to do what? To decrease. It will start to decrease. That is it, and that is the end of our discussion for light intensity. Our next slide will be for the carbon dioxide concentration.